I'm going to begin example number 4 by typing everything into the calculator, and so let's do that together. So I'm going to turn it on first, and then I'm going to click second matrix to get into the matrix menu. Then I'm going to go to the edit command and start putting the data in. I'm going to put everything in matrix A, and this problem here has 3 equations, 3 letters, plus the extra column for the numbers. So it's a 3 by 4 again, so I'm going to click 3 enter, 4 enter. And as usual, you don't have to clear or delete anything. You could just type the new numbers on top of the old numbers. So the first number in my new problem is 3. Just click 3 and then hit enter. Then tiny little -4 and so on. So -1, 6, and keep going. 2, -1, +1, -1. Then finally 4, -7, -3, and 13. And it takes you back to the first spot. And even if all your numbers are not visible, like with some of the older TI calculators, it can only show 3 columns. It doesn't matter. It has normally little 3 dots right there, and you can scroll and see the new numbers. But I'm gonna make sure that I typed all the numbers in correctly, and it seems like it's good. So far, so good. So I'm gonna go second, and then quit. So this time, I'm gonna go ahead and ask for the calculator for the row echelon form, then the row reduced echelon form. So I'm going to click second, matrix, then go this time to math, and then it's easy if I go from the bottom all the way to find REF, row echelon form, and then I tell the calculator the name of the matrix. So matrix, second matrix, and then matrix 1, close parentheses, then click math 1 to put everything in fraction form. So there you go. And if I do the RREF matrix, then I'm gonna get this. So RREF matrix, and then the matrix A. So matrix A, close parentheses, and then go math 1 to get the fractions. As you can see right there, my last row is funky looking. It's got all zeros everywhere. So that's gonna be a special case. When that happens, we call this a weird system, basically. So something strange is going on. This is one of those cases where you could have no solution, or you can have many solutions. It's just weird because we're getting zeros for the coefficients and zeros for the number. So depending on how it looks down here, you could have either a no solution situation or a problem with infinitely many solutions. So let me go ahead and write everything down on my PDF next. So by copying the things that we got from the calculator, we end up with the REF and the RREF matrix. So let's try to understand what this last matrix is saying. So that last row is pretty much saying that 0 is equal to 0, which is a true statement. This is a true statement, which means that our problem is going to have infinitely many solutions. And the way we get them is by looking at the other 2 lines. So the middle line says something about x, y, and z, and the first line says something about x, y, and z. Remember, the x's are always first, the y's are in the middle, and the z's are at the end. So let's read the first equation. First equation says 1x, no y's, plus 1z is equal to -2. The middle equation says 0x, 1y, plus 1z is equal to -3. So let's try to isolate the letter x by itself and the letter y by itself. So I want the x by itself and the y by itself in terms of the z. So in this case, if I isolate the letter x, I would have to subtract z from both sides. So -2, -z. And if I isolate the letter y, I'm going to end up with -3 and then -z again. And that gets me the x's and the y's. So what's my solution going to be? So in this case, the solution is going to be kind of weird looking again. We did that once before. It was x, y, z, except we don't know what z is, so we're going to write down any random number. The y is -3, z, and the x is -2, z. So the answer basically depends on what your z is. You can pick any number you want for z, and if you do, the x has to be -2, the number you picked, and the y has to be -3, the number that you picked. So that's what this means. It just literally means that your system is dependent. There is more than one solution. This is the next problem that was on the problem, and again I end up with a row of all zeros. So again, I'm going to interpret that as 0 equal to 0, which is a true thing. So having 0 equal to 0 is not terribly bad. It just means that your answer is going to be a little bit complicated. So Let's try to interpret the second and the first equation. So again, keep in mind that the x's are always first, the y's, the z's. So the first equation is basically telling me 1x plus 0y plus 7/5 of z is equal to negative 1/5. The second equation is telling me 0x, so no x, y minus 4/5 z is equal to 7/5. And remember, I'm trying to get the x by itself and the y by itself when I'm doing these problems. So I'm going to try to solve for x on the first equation. To do that, I'm going to end up with negative 1/5 and subtract the 7/5 to get the z across. And the second time I do this with the y, I just add 4/5 z to the other side. So add 4/5 z, there's already the 7/5 already there. So my solution this time is going to be an ordered triplet, except it's not three numbers, it's three quantities. The first one is negative 1/5, negative 7/5 of z, then 4/5 z plus 7/5 for the y, and then we don't know what z is, so we're going to leave it alone. So basically this says, give me the z and I'll give you the number. And obviously z could be anything at once, so there are more than one solution. So this is the reason why we call this system a dependent system.